There's this quiet revolution happening, like right under our noses. It's a totally invisible upgrade, but it's making our entire high-tech world possible. Today, we're going to pull back the curtain on it.
So, when you think about what powers AI, what comes to mind? Probably massive data sets, right? Or these super complex algorithms. But what if the real bottleneck, and the next giant leap forward, actually comes down to something as basic as the voltage running through a wire?
And see, here's the heart of the problem. Our world, everything from AI and 5G to the enormous data centers that basically run our lives, is demanding way more power, all crammed into less space. And the way we've been doing things for decades, it just can't keep up anymore.
And that, right there, is where we run into a hidden problem. All this incredible technology has created this massive challenge, not in computing power, but in actually delivering the electrical power to make it all work efficiently.
For years and years, the standard has been the good old 12-volt system. It's been a reliable workhorse, for sure. But as the power demands have just skyrocketed for things like high-performance GPUs, our old 12-volt friend is, well, it's hitting a physical wall.
Okay, so what is this bottleneck really? Why is 12 volts suddenly not cutting it? Well, it all comes down to a little bit of physics.
Okay, imagine power is like water flowing through a pipe. To get more water through, you've got two basic choices. You can make the pipe wider, which in our case means using thick, heavy, expensive copper wires, or you can increase the pressure. And in the world of electricity, that pressure is voltage.
And just look at the staggering difference this makes. Let's say a big server needs 1,200 watts of power. At 12 volts, you have to shove a massive 100 amps of current through the wire. But if you up the pressure to 48 volts, you only need 25 amps. That's just 1/4 of the current to deliver the exact same amount of power.
Now, why does that matter so much? Why is less current such a big deal? It's because of this fundamental law of physics. The power you lose, the energy that just gets wasted as heat, is equal to the current squared times resistance. The most important part of that whole equation is that little I squared. That means the power you waste doesn't just go up with the current, it goes up exponentially.
And this is the punchline. By cutting the current down to 1/4 of what it was, the 48-volt system doesn't just cut waste by 4 times, nope. Because of that I-squared rule, it slashes the energy lost as heat by a staggering factor of 16. That is a total game changer for efficiency. So, this simple principle is leading to a really elegant solution that engineers are starting to use pretty much everywhere.
And the benefits here are just huge. First, obviously, that massive jump in efficiency means way less energy is just wasted as heat. For a giant data center, that could mean millions in savings and a much smaller carbon footprint. Second, less heat means you don't need as many crazy expensive cooling systems. Components can be smaller and lighter. And that stable, clean power delivery is absolutely crucial for protecting those super expensive processors that run all our AI.
So it's really no surprise who's jumping on this first, right? The most power-hungry, demanding applications on the entire planet are the ones leading the charge. We're talking about the world of high-performance AI and the hyperscale data centers that are already aggressively switching over to this new 48-volt standard.
But this whole idea doesn't just stop inside a server rack. It scales up. It scales up dramatically. Just think about the power needed for something way bigger, like the thousands of base stations that make up an entire city's 5G network.
And that same idea, higher voltage, lower current, when you apply it at that kind of massive scale, is called high voltage direct current, or HVDC.
Don't let the name fool you. HVDC is literally the exact same principle we just talked about. You crank up the voltage, which lowers the current, which means you waste a whole lot less energy. We're just going from a server rack to entire cities and even countries.
And its impact is profound. HVDC is absolutely essential for powering these sprawling 5G networks efficiently. It's being used to connect the power grids of entire countries so they can share energy. And maybe most importantly, it's the key to bringing huge renewable energy projects, like those massive offshore wind farms, onto the main grid. It lets us move clean power over hundreds of miles with very little waste.
So as you can see, this is so much more than just some minor technical adjustment. It's a foundational shift. It's what's enabling the future of our technology and our energy grid.
And if you want to know just how big of a deal this is, well, just follow the money. The market for the special converters that make all this possible is projected to absolutely explode. We're talking from around $3.3 billion today to over $27 billion in just a decade. That is a massive bet on this technology.
Because at the end of the day, this shift to higher voltage, it's about way more than efficiency. It's what makes the next generation of AI even possible. It's what makes a modern, renewable-powered grid actually feasible. It is a fundamental enabler of the future we're all trying to build.
And that really leaves us with a final thought to chew on. As everything in our world gets more connected, more digital, more electric, maybe the next truly great innovation won't be the next amazing gadget or AI model. Maybe it will be a smarter, more efficient way to power it all. Thanks for tuning in.